you, my dear students. Teacher Kakuru, once again, I told you that I will continue adding a concept on a daily basis. Yesterday we looked at resistor calculations. Today we are going to look at circuit calculations. Circuit calculations. We are going to consider a simple circuit. We are going to consider a simple circuit to start with. Consider a simple circuit. And we are highlighting a case study on the use of Ohm's equation. If we consider a simple circuit with two resistors connected to a source of EMF, connected to a source of EMF of 12 volts, as indicated there. The resistances are 2 ohms and 4 ohms respectively. We can be asked that using the diagram above, they can ask us to calculate the current I. Calculate the current I flowing through, for example, the 4 ohm resistor. Through the 4 ohm resistor. Now, we will begin our solution by looking at finding the effective current, effective resistance. To find effective resistance, that is the first requirement. The first requirement is for us to find effective resistance. And you will notice that since it is a one-wire circuit, the effective resistance R will be obtained by adding the two resistors we have, and this will definitely give us 2 plus 4, which will give us 6 ohms. Then we shall use the Ohm's equation, that V is equal to IR, where our V is the potential difference, our I is the current we are looking for, and our R is the total resistance which we have got. If we substitute in this formula, our 12 volts, which is obtained as our V, and our R, which we also got as 6 ohms, are substituted in to enable us find I. And by mathematical calculation, our I becomes 12 out of 6, which will give us 2 amperes. Our I becomes 2 amperes. That is one first quick example there. We can proceed to practice with another different number. Here, we can proceed to practice with another different number, but before that, we can conclude and say that the current they want through the 4 ohm resistor is 2 amperes. You must conclude, because the question was telling us to find the current through the 4 ohm. Example number 2, we can have a circuit diagram. This is slightly different from the first one, where we have several resistors. We have a network of resistors here, as illustrated in the circuit diagram being drawn. And the arrangement is connected to source. Is connected to source that has a battery, again, of resistance 12 volts. The different resistors are 1 ohm, 2 ohms, 2 ohms, and 4 ohms. With that circuit diagram, they are telling us that using the diagram above, they want us to determine 1, the effective resistance, 2, they want us to determine the current that passes through the 1 ohm resistor. 3, they want us to determine the current that passes through the 4 ohm resistor, and they also want us to find the PD across the parallel resistors. The PD across the parallel resistors. That is the question. And we want to look at that question right away. We begin our solution. We begin to work out that number by finding the effective resistance. Let us find the effective resistance in the parallel arrangement. In the parallel arrangement, parallel arrangement has resistors of 2 and 2, and then they are connected with the 4 ohm. So if we let R be the effective R1, it is going to give us 2 plus 2, which I said is with a 4. So the effective will be product over sum. These two combined over the 4 plus the 4, and that effective is going to give us 16 over 8, which will definitely give us 2 ohms. That is the effective in the parallel arrangement as picked out from there. Now, if that is that result, R1 is now in series with the 1 ohm resistor. So our circuit diagram now looks like this, with this as R1, this as the 1 ohm, and of course it is connected to the source. That is now our circuit. So the overall effective resistance which they want in part 1, the effective resistance which they want in part 1, which I'm now going to call R, will be equal to 1 plus the 2. And this will give us 3 ohms. That is part 1, because it is a series arrangement. Now, part 2, to find current, through the 1 ohm, through 1 ohm resistor, we use Ohm's equation. V is equal to IR, and I is what we want, V is 12, and R is 3. That is the current that will pass through the 1 ohm, which is going to give us 4 amperes. So we can say that the current through 1 ohm resistor is going to be 4 amperes. I am going to look at part 4 first, because the part 4 is required to find the part 3. That when we come back to our diagram here, we are saying this current is 3 amperes, and when it reaches here it will divide up, say into I1, which they want, and into I2, which they want. But look, this plus this is the same as this. So it means I1 is actually going to be equal to I2. And therefore this current is going to be equally divided. But since we are able to get the effective resistance here as 2, it implies that the PD across the parallel arrangement, if we let it be V1 be the PD that we want across the parallel arrangement, then we can say that V1 is going to be equal to the current passing through the arrangement here times the resistance R1, because R1 was the effective in the parallel arrangement. So the PdV1 will actually be equal to the current, which is 4 amperes that we have got flowing through the 1 ohm, times the resistance effective R1, which we got as 2. And therefore, this can confirm that the PD across the parallel arrangement is going to be 8 volts. 8 volts. And therefore, we can now finally come to part 3 and say that since V is equal to IR, then our V1 will be equal to the current that I've called I1 times the resistance of 4. And our 8 will therefore be equal to I1 times 4, implying that I1 will actually be equal to 2 amperes. Therefore, we can conclude and say that the current through the 4 ohm resistor is going to be 2 amperes. That brings us to the end of the 4 parts. The end of these 4 parts are clearly solved, with the effective resistance starting over from here, but giving us our final resistance at this stage. The current through the 1 ohm at that stage, and then the PD across the parallel arrangement being this, implying that that PD must be used here. That is the PD that I have called V1. It must be used to find the current. But we have said that the current will divide up equally, since this and this will have an equal value. And therefore, that brings us to the end of those 2 numbers. But I will be giving you some 2 more numbers, maybe 1 to try out, which I will put or announce that you can check. You can check in the question bank book. Let me simply summarize it. 2006 and 2007, paper 2, and try out those numbers. Try out those numbers about the same. I thank you very much. See you again.